Okie dokie, so today we're talking about DNA translation, but this is going to be the coding part, the code on part. So what we're going to start with is the fact that we have 4 bases and 20 amino acids to code for. So a codon we know consists of 3 bases, but this is kind of the math of why. If it was a 2-base system, then statistically there would only be 16 possible outcomes, and with 16 outcomes you can't code for 20 amino acids. So I guess nature bumped it up to a 3-base system, and so then we have 4 cubed. You can look at it like that. 4 cubed equals 64. So then we have a total of 64 combinations, and that's greater than 20. And actually, we're going to have some overlap with that. And so then when you lay out what the bases are, the A, T, we'll circle those, then C and G, you can lay them out in a chart, and the chart looks something like this. And so you can look, okay, so if I have my A, C, and then U, oh, that's going to be THR, and that's the amino acid it's going to code for. And so it's simple as that when reading one of these charts. You can also have circly versions. It's the same thing. You start with the letter, then you move to the second letter, then you move to the third letter, and that is your amino acid that's going to fit for that. And so I have a little thing here to mimic that with some little tRNAs here. I have my mRNA sequence, and then just to go over the anticodons once again, because this is a codon chart and it says for the mRNA nucleotides here. So when we're coding, this is for the mRNA sequence, not the tRNA sequence, because they will be different. They'll be the opposite. So AUG. So if I look, AU, then G is right here. That stands for MET, so I'm going to write that here for my amino acid. That is the start code. But if I want to find the anticodon for that, I just have to look at the code and reverse it. So A is going to go to U, U is going to go to A, and G is going to go to C. So that's going to be the anticodon. So on the tRNA, it's going to have a UAC on it, and connected to it is going to be the MAT. I drew like this is kind of what an anticodon or the tRNA kind of looks like, and the anticodon is going to be down here. But then I just kind of drew these funky looking T-looking things. So GAA. So G and then an A. So we're in this box, and then A again. GAA. That's a glue. GLU. These all do have longer names, but I'm not going to cover those. So G goes to C, A goes to U, A goes to U. That would be the anticodon. Do it again. GGU. G is right here, G is over here, U is up here, GLY. I think that's like glycine, so CCA. And then UGC, UG, U, G, and then C. So that's going to be cytosine, CYS. The anticodon will be ACG. And then here, I wanted to put a special one. So I'm going to look here, and I'm going to put UGA. UGA. So the anticodon might be ACU, but there's not going to be an amino acid for it, because these don't code for amino acids. They just code for the stop. And so after this, we'd have our poly A tail, and that would be over here. We'd have our methyl cap, and that's kind of all that goes down, and that's the coding bit for DNA translation. Just remember, you start with the first, then the second, and the third, and that's why we have a 3-base sequence, is to get 64 and code for all of these. And the robustness of the system is great, because if we look here, if we have CC, the first 2 bases, any of the third base, if that's mutated, then it will still code for the same amino acid, and that guards against mutations. And I hope that was helpful.